同学，大家好哈。今天是我们无限的光荣跟荣幸，请到这个联合国前统计司长Paul 来这边为我们做这个 Big Data 的分享哈。那 Paul 现在已经在全球各地到处去建构跟推广这个 Big Data， 还有统计的分析哈。那从联合国的工作线下来，他其实对统计的使命其实是更有机会去全球，甚至主要是在华人或亚太地区去做宣扬哈。那他是一个非常让我非常敬重的长者哈。那么今天我就不用讲太多话，把时间都留给我们的 Paul， 然后我们热烈掌声欢迎 Paul。
谢谢，很高兴能够来这里跟大家谈一谈这个 big data 的事。那时候开始做这个东西的时候，跟这个谢教授一起来讲这个问题，还请教过这个谢教授，所以要多谢谢教授给我这个很多帮忙。我本来说是要用英语讲的，但是我现在可能要试一试用中文讲一讲，一起来讲了，好不好？我要训练一下就是我的这个国语啊。这样今天我讲的题目就是讲这个 big data 跟这个官方统计还有这个 social science research 这个关系是什么样的啊？还有现在很多人重视这个问题，这样先讲一讲我自己的背景吧。我在新加坡大学先教书，后来去了新加坡的这个统计局，做了统计局的局长，做了14年。后来从新加坡去了联合国，在联合国做了联合国的统计长，做了有9年。在联合国的统计长的话，就是在全球代表全球来管理全球的这个统计的系统。所以在纽约9年够了，所以我觉得回来亚洲回新加坡比较软一点，not so cold。但是在我们那边，我的工作是做什么呢？我们工作是做这个 global information system。How to build 这个 global information system？ 因为 global information system 有几个 elements， 第一就是讲这个common standard， 同样的标准，还有讲这个 data exchange， 讲这个 quality assurance， 讲这个 data dissemination platform。还有 global governance arrangement， 你们要有 global system， 一定要这种最重要的东西。像我们在联合国以联合国的平台来做这个，像全世界这个统计的系统是以这个联合国这个统计委员会为主，这个是 governance system。像每一年我们出很多标准，在全世界的做这个调查，做这个统计以这个联合国的标准为主。所以我们是这样来做这个整个全球性的这个 system。但我们那时候做这个 global information system 有3种最重要的资料。第一就是 official statistics， 这个我们都很熟了，官方统计。官方统计我们在联合国有60多年的经验。第2次世界大战2次世界跟我们一开始做了一路来我们做了很多不同的statistical standards。最重要的当然是我们这个 SNA System of National Account， 全世界怎么来算这个 GDP？ 你看能够这个 GDP 多么重要，但是在世界上这么多国家说到 GDP， 我们算这个方法都是一样的。这个也是因为联合国那里我们出这样每几年我们会改一改修正。现在最新的那个是2008 SNA。做 official statistics 我们很熟，我们一路来有跟他们做工作。但是现在做这个 information system， 不单只是这个 global 这个 official statistics， 最近我们开始拉过去是这个 geospatial information 地理信息。地理信息越来越重要，有很多地理信息，这样地理信息跟这个官方统计两个关系很密的，但是我们有时候拉起来，有时候没有拉起来，有几个国家特别拉得比较密一点，巴西啊、墨西哥、Mexico 是有，他们这个 统计局跟地理信息这个两个是在一个局里面来做的。所以我们最近要把这个 National Geospatial Information 再加进去，所以现在在弄，就 integration of geospatial information and official statistics。但是后来我们发觉了这个还不够，有一个 missing， 因为这个 official statistics 跟这个 geo information information 都是 structured data。Very well defined， 但是现在越来越多是 unstructured data， 所以现在我们就讲了第三种 information， 第三种的消息，就这个就是 big data。就这三方面能够把这三方面都能够弄好的话，在我们整个 global information system 呢，全球性的这个系统呢就能够做得好。但是不容易，因为在官方统计，我们有一个统计局来做，在台湾是叫做主计处啊。你们这里在讲这个 geospatial information 的，有一个测绘局啊，或者是你们在台湾叫有的可能是 Ministry of Interior 来做。但是讲到 unstructured data 呢，都不知去哪里，就还没有一个单位去负责这样的数目字。但是但是 big data 是很新的，每个国家还在这个研究这个问题 ，they're struggling with this issue。这个你看看这个图，这个图是从 Google Search、Google Analytics 看出来的，就是看人家看how many people search for the term big data。你看最近那几年跳得很快，这个是 relative to the number of search。这个你可以看到这个the importance of big data。第二个就是看最近这个 big data 在 media 也是很多了。这个是有一个人要进去 immigration， 他们说已经查到你上 Google 啊，上这个Twitter 做过什么坏事啊，都一查就查出来了。所以现在你看这个很多的不同的用法，在这个 media 当中也有这个有这个 reflection 怎么用。但是问题是有这么多的人来讲这个 big data， 到底 big data 是真的还是假的呢？So the big data is what's the big deal？ 有什么特别呢？我要用我自己的 slide。So 这个 big data's characteristic 就是is a no fixed definition. So but what we know is that it's unstructured， 没有规律的，是吧？unstructured, unregulated。这样最重要的 definition 你们就知道了，可能跟这个教授听过，这是最重要是有这个 4V 这个 definition， 这个 volume、velocity、variety and variability， 这个 4V 这个 basic defining characteristic of big data。就还有再加上我们这个知道这个 complexity of the data。So these are all usual definitions. When we talk about big data, we know that it's not a single source of data, but multiple sources, very different varieties, and unstructured. And also the data 这个come from many sources， 从很多地方不同的来到啊。我们知道有这个 social network、internet administrative sources。我们在讲到台湾，好像你们这个 health insurance database 很多不同的资料。So these are all the possible sources of information。我现在要开始用英语讲了吧？So let's give you some example of the applications of big data, which shows that why the big data becomes so popular and becoming so important. This shows the prediction of the sales trends about some of the car sales, Chevrolet and Toyota. And then this come out from the Google in the earlier days, 2009, when they actually can predict the sales of cars very well, using some of the search functions in Google, finding out the keywords and using those keywords as a search basis for Google. So that's quite interesting. When this thing came out, it basically shocked the world that there are additional data that can be used from the Google search as a basis of predicting economic trends. So that's the big promise, because everybody looking for new indicators of how to predict future economic trends. And the prediction is very well, very good. So at least in appearance, 看起来很好看, a perfect match. But that's a problem. Later on we'll talk about it. And this is the latest. This is about the happiness, measurement of happiness using the Twitter data. And they come up with a new term called hedonic matrix. And this one comes from the UK. And then basically they look for certain words. And when these words come out, they give it a ranking. And then they come out with this particular set of indicators, whether the people are happy or not happy. And then they also use it for the national moods. Again, going to the Twitter, looking for certain indicators. This comes from a PhD thesis. The graphs are not very good because it's a screenshot, the color, but it shows the changing of the mood depending, going by the Twitter data. Now these are some of the examples, from economic prediction to the national mood estimation or understanding the national sentiment. And then there are some other more traditional areas. In this case, in Singapore, there's one health network. It's not as good as Health Insurance Corporation here, but they run about 1,000 clinics. So they have many claims. Patients going there to the clinics. The clinic will look at the patient. They will have a diagnosis. They will have the medicine prescription. They will have the charges. All this information are captured in the system. So over time, there's a lot of data there. And so this is a very valuable source in Singapore, and this constitutes part of the big data coming in from administrative sources. And this shows one of the fraud detection that is discovered, that when you look at 1 million databases, and then once you start having establish a trend, and then anything out of the trend line become obvious. So this shows that some of the patients have additional, I think this one is has much higher claim than average. So these are problematic cases. So they use this and then to go in and to detect whether there are any fraud, any potential cheating. And there are some cheating examples. And particularly some doctors who like to prescribe expensive medicines, even though they have not actually prescribed it. And, but then because the claim is high, so they get detected. So they use this kind of big data for fraud detection. So this is actually very common in America. A lot of them actually use this kind of data for commercial purposes. In Singapore, we also have this electronic road pricing. So it's like when the car goes through, we charge the usage of the car. So whenever you use the car, there will be a charge. So that means the car will go through the road, and there will be a signal. The signal will detect the car and then will deduct some money from the bank. So very basic principle. So but there are many different points, and then when they detect they detect the owner of the car, what kind of car it is, and then of course they deduct the amount of money. And there are many different points for deduction. So if you match this with the database, you will be able to see who are the people driving, how much they are being deducted, and how the deduction relative to the household income, how much of it is, how big it is, so that you can know whether the charging is having impact on the person's driving habit or not. If you ultimately you believe in behavioral economics, you want to use this kind of charging mechanism to affect human behavior. You want to know whether the charging level is making an impact relative to the person's household income. And so this kind of data matching with the background data will allow you to model different kind of driving behaviors. This is a bit like in the Nordic countries. In the Nordic countries, if you are commit traffic offense, if you are stopped by a traffic police, they will charge you. Then they will fine you for the traffic offense. But the traffic offense is variable. So they will ask you for your ID. They will go to the computer, handheld computer, key in your ID, and find out how much are you paying your income tax. So the higher the income tax, the higher the fine. So you can pay $1,000 over for the traffic offense because if you are a high earner, and then if you are a poor person, you pay only $10. So that is, I don't know whether it's good or bad, but they believe in proportionate to income. But what we want here is not so much of that, but it's more like if you want to regulate traffic, you want to make the pricing mechanism relevant to the household income wealth, and then this allows us to do that. And so there are some analysis being going on, and we know that the big data are coming in from many sources, and then also the handphone become a very key source, and also from the geospatial point of view, any device can become a source now for the generation of big data. And this is an example, a hypothetical example, but I know that New York City is tracking it. So assuming that on a normal day, say in Manhattan, you have a normal distribution of the handphone signals. So this depends on where the people are, you have a normal distribution. And then, but during some special events, the handphone signals will start congregating. It could be a football match, or it could be, in this case, a July 4th Macy's firework. July 4th is the day before Independence Day. So in New York, there will be a firework over the river. So it's a very big thing. Millions of people will congregate along the riverfront. So if you are tracking the mobile signals, you will see the signals congregating in some areas. So the police are using these kind of devices to track the movements of people, particularly if things start happening. So if there's a football game going on and people are going there, and then you map the signals over time, you'll be able to see the signals converging into a single point. You know that whether, if it's a football match, it's okay, but it could also be a riot. But if that's the case, it allows you some leeway to intervene when you start seeing this kind of dynamic movements of mobile signals. In 2008, when China was having some problem in the economic crisis in Shenzhen and Dongguan, so a lot of migrant workers were moving away from Shenzhen. So they have no idea how many have moved, how far they have moved, and then but they know their movement because the factories are closing. So knowing the migrants' location become an important policy issue, or the dispersion of the workers in the economic downturn. So what they do is that they track the handphone signals, because if they are all registered in Shenzhen, and if the handphone signals are coming in now from other cities, then they know that the owner had already migrated to other places. So using the handphone signals allow Chinese authorities a way of analyzing the dispersion of the people, but even though at that time in a very limited way. So the big data, the question now we want to ask ourselves with all this hype and some useful examples is that are they really, really useful? And what are the problems to making them even more useful? And so the conclusion is that there seems to be a lot of hype, you know. A lot of people get very excited, but we don't have that many really useful implications as such, application as such yet in social science research. Mostly are used in the commercial and the security applications, and then in detecting fraud, in generating consumer profiles, in reducing medical costs. So all these are happening. So mostly used by the corporations to improve their operations. But in social science research, we haven't used it that much. Then the question is why? Why we have not used it in in social science research and in official statistics. Because they are not being used in social science research, then people start saying bad things about us. And these are the bad things that they say. Because there's so much data going on now, coming in, that we don't need any more scientific methods. The scientific methods are the one that you learn in your basic social science research. How to do a survey, how to test hypotheses and all that stuff. So the data deluge doesn't make scientific methods obsolete. And then they also said that the official statistics and all the others depend on the classical statistical methodologies. And so because of that, all the social science models and methods become obsolete. That means big data alone can solve the world's problem. But we know that that's not possible. So then the question why? What is the difference between the big data approach, its theory, its method, as compared with what you learn in school about the social science methodology? So let's talk about the official statistics. This is the first structured data. In official statistics, for example, we do a population census. We want to know about the population characteristics, or when we want to know about the value added of the corporations, the economy, we need to know the company's profit and loss. So we start with a research problem. We define the issues, the variables. We go out and collect the data. So in this case, from the census, you group people together. You decide on the questionnaire, you find out what are the indicators you want to measure, you go out and get the data. So everything is very clear, everything is predetermined, so everything is structured. So we have our own way of doing things, we know exactly what we want to get and we go out and get it. So the same is with the corporations. So our survey of investments, survey of profit and loss, all the forms that we issue in official statistics are very clear, very clear. We know exactly what we want. In the social science, the same thing, right? We start with a hypothesis. We want to test the hypothesis. So when we go out and test the hypothesis, our questionnaire must be structured in such a way to collect the relevant data. So in our school, we have been trained to how to do a proper questionnaire. The questionnaire must be very clear, you must get a correct response, you want to reduce the response bias, you want to reduce all the errors and mistakes that you can make from the instruments that you administer in the person-to-person interview and so on and so forth. So when I went to school many years ago, when I do the social science research methodology, that's the thing we learn. How to set up the hypothesis, how to set up the research method, how to do questionnaires, how to avoid response bias. All these are essential classes before you get a PhD or something. That's the basic social science research. So the basic social science research start with a hypothesis, there's a research methodology, you collect data and then you analyze the data. So that's very straightforward. But then what's the difference between the social science methodology and the big data methodology? This shows the difference. In the social science methodology, we go out to the population, we want to estimate the population mean, the capital X, we do a sample, we estimate the population, then the sample mean, small x, right? And based on this, we can use all our inferential statistics. We can do all the statistics based on this probability and all the curves, and then we come out with a conclusion. And in the process, we test our hypothesis, and when testing our hypothesis, we can do the statistical testing, whether statistically significant or not significant, so on and so forth. But in big data, we can't do that because we are not sure what is the underlying population. There's no capital X, there's no population mean for you to estimate. And you're also not sure the sample that you draw, whether it's representative or not. So you have violate all the principles that you learn in your social science research methodology. Then what is the research methodology in the big data? The big data, the population itself is evolving. The data coming through day to day may be very different. You never know. But what they do now is that they stop the population for a while. They, based on the population, they go in and look, they draw a sample, they look for patterns, they look for structures and identities, and then having identified the pattern, then they go back and check again. And at the time the population will have evolved, but then they will check to see whether the structure, the pattern, the identities are still holding or not. So it's a bit like try to build something out of nothing. Building a house based on a lot of information, but you are not sure whether information is valid or not. So after you build this house, you need to go back and verify again and again to see whether your thing is accurate. But then because it's a house built on nothing, so you never really know what is the reality. And so we'll address some of these issues. So let me just, before we go into some of the more complicated issues, let me just say a few things about how we can actually still make use of the big data. Now, we know for a fact that because the way the research is being done, the data is being collected, we know that big data cannot replace the traditional data sources. So it is not reliable enough. There's some limitation about its representation, about its reliability, but it has a lot of potential because the data coming in are very fast. We can make use of them, and they come in different varieties, and the data mining techniques are now getting better and better. And so, and this also, big data allow us to get away from the traditional official statistics data sources, which by survey. Survey is very slow and then and very that's why people don't want to wait for official statistics because they take forever to come out, and then they want whatever source there are, new sources, they want to jump on it. So this will give us a push to use news data sources. So for example, like this is the famous University of Michigan Consumer Sentiment Index. We all know that, right? They have been doing this survey every year since 1950s. The panel study, they follow this panel and ask them about their sentiments. And this turned out that this sentiments index is a very good prediction of the economic cycle. So yeah, it's very famous. But what they do is that some people are using the Google search, based on all the search elements, they are able to find the structure and replicate this consumer sentiment index very closely. From the index, they have different sub-indexes, and then and they are all able to replicate it very closely, and then and this one shows that they actually can predict it very well. Now, what it does say here is that, in other words, you don't really need the Michigan Consumer Sentiment Survey as a predictor for the economic performance of the future of the US. What you need now is to have a new artificial index based on the Google search and certain keywords which match it very, very well, and then use this artificial index as a way of replacing the Michigan Consumer Index. And another example is this unemployment trends. Again, it tracks very, very well. So in other words, we know that there's an unemployment trend. We know that the sentiments are moving. We go into the Google, the big data, we look for the structure that will simulate, that will represent the same kind of structure as the same kind of movement as the sentiment index and unemployment rates. So